So yesterday we left at this stage when we were doing our uh, acid derivatives. We were starting, right? We had to do the names of acid derivatives. Is that correct? You remember this point? So from here we are starting. As you all know, the acid derivatives is OH is removed by some other group and now derived from carboxylic acid. So RCOH, say we are using then RCOCl, anhydride, ester, amide, all these are called acid derivatives. Now carefully you see acid chloride, RCOCl, the suffix is oil chloride, but the prefix is haloformyl or halocarbonyl. Both are accepted, and while alphabetizing, you will start from H. Okay, for alphabetizing, you will refer H as this. And the special suffix we yesterday discussed one table. As per that, it is going to be carbonyl chloride. Please attempt these 4-5 questions. I hope that will help you. Okay, so moving to esters. Same way as we did for alkyl chloride esters, but there is one very important difference about esters. Special suffix is carboxylate, and the way you name esters is alkyl alkanoate. And when we say alkyl alkanoate, this R dash, which is attached to this single bonded oxygen, is to be named first, irrespective of alphabetizing. This is the alkyl and this is the alkanoate. So whatever present in this R will always be written after mentioning this R dash. Okay, and there are also two suffixes, two prefixes. When it is attached with oxygen on a principal parent chain, then you call it alkanoyl oxy. And when it is like this, then it is alkoxycarbonyl. Now this we have exemplified here. Please check. Check all these four. I think these four are simple, like methyl ethanoate, propyl methanoate, right? Now here, this carbon cannot be included in parent. So methyl cyclohexane. It is not cyclohexyl, cyclohexane carboxylate, right? Now, yes, there are two ethyl. Again, diethyl, you don't have to speak diethyl. When you are saying di-OH and you are referring as ethyl, it is understood that both have identical. So it is ethyl propane 1,3-dioate, DEM, diethyl malonate is a common name which is used much more. Okay, please remember cyclic esters are called lactones and cyclic diesters are called lactides. Carefully compare 5 and 6, these 5 and 6. Please compare this 5 and 6. What I just told is applied here. Okay, I got it. Moving to amide. Again, same thing. Suffix is oic acid amide. But prefix is carbamoyl and special suffix is carboxamide. So this carbon is to be included in parent chain. So it is called methanamide, ethanamide. But here we will use the special suffix. So cyclopentane carboxamide. CuNH2 is part. Okay. Cyclic amides are called lactam. And please attempt fourth. How will you name it? Okay. Great. Anhydride. Suffix oic anhydride. Special suffix is carboxylic anhydride. It does not have any prefix. Okay. Just attempt these 3 questions. That would be it for anhydride. If there are 2 different acids, then we have to place them in alphabetical order. Ethanoic, propanoic anhydride. Okay, Shreya, thank you. Cyanide and isocyanides. Now, again, cyanide's carbon will be included in parent chain. Isocyanide carbon will not be included in parent chain. Cyanide has a suffix of nitrile and special suffix of carbonitrile. Prefix is cyano. Please attempt these 4 questions. And these are all practice questions, right? I don't think all these can be done and are required. Let us go to miscellaneous. So if it is RSO3H, it is alkane sulfonic acid. RSO2H, then it is alkane sulfenic acid. RSO3R dash is alkyl alkane sulfinoate, like methane, methyl benzene sulfinoate. Okay. And that brings us to the closure of lecture number 4. Lecture 5 is little, uh, more writing will be there. Nomenclature of aromatics. So we follow everything to be same, like aromatic compounds. At this stage, we mean benzene and its derivative. Only those we'll consider for IUPAC nomenclature as per syllabus. Rules used to name cyclic compounds are retained, okay, for aromatic. For IUPAC of substituted benzene compounds, a substituent is placed as prefix to the benzene. For example, like this, nitrobenzene, bromobenzene, like this. IUPAC has retained many of the popular names like methylbenzene, IUPAC. You can call it methylbenzene, you can call it toluene. You can call this as a methoxybenzene or anisole. Aminobenzene is equally accepted as the word aniline. Okay. If there are di substituted, then yes. If you are using the word orthometapara, then it is a common name. For IUPAC, you will use the word 1, 2, 1, 3, 1, 4 type things. Now, here, ultimately, you have to remember certain names over a period of time. So, first, I'm starting with mono-substituted benzene when only one group is present on the benzene. So, methylbenzene, toluene. Chlorobenzene, right? Phenol is retained as phenol. Styrene. And please remember, styrene is not called phenylethene. It is called ethynyl benzene in its IUPAC. Okay, its IUPAC is not phenylethene. It is ethynyl benzene. Isopropyl benzene, which is commonly called cumene, 1,2 diphenyl ethene. Okay. Methoxybenzene is anisole. Ethoxybenzene is phenitol. This has two names. Either you can call it as benzaldehyde or benzene carbaldehyde, like the cyclic systems you can name. This yesterday also I told you phenylethanone or acetobenzene. But when I am writing a circular bracket, it is not accepted by IUPAC. So phenylethanone, benzophenone or diphenyl methanone, benzoic acid or benzene carboxylic acid, benzene sulfonic acid, benzene carbonitrile or benzonitrile. See, not benzene nitrile, it is benzonitrile. Nitrobenzene, benzoyl chloride, benzene carbonyl chloride, methyl benzoate or methyl benzene carboxylate, benzamide or benzene carboxamide. Okay, N-phenyl ethanamide. Now, see, this is amide and nitrogen has benzene. So, it is N-phenyl ethanamide. It is also called acetanilide, acetyl group on aniline. Okay, phenyl ethanoate, aniline or aminobenzene, N-dimethyl benzoic anhydride. If there are two groups present, then these are the names. I'll wait for 30 seconds. If you want to write anything, you can write. Mono one, I hope you all remember by now. Okay, so we have xylenes as common name, orthometapara. Cresols when CH3 and OH is there. 4-methylbenzene. Now 7 and 9 are very important. Salicylic acid and salicylaldehyde. They are in fact more famous by their common name. Moving to next. Phthalic acid, benzene 1,3, dicarboxylic acid. Just go through them. If you want to write anything, you can write. Next page I have shifted. Now again, wherever I have marked these stars, those are very important names. You have to remember them. These are all painkillers, 19, 20, and 21. These are all painkillers which are used in medicines. The last page of disubstituted. Okay, Shrey. Coming to tri-substituted. Mesitylene, pyragalol, benzene 1,2,4 triol. Okay. Now in tri-substituted, I want to add one more which is very famous, and it is OH, OCH3, CHO. This is called vanillin. The vanillin essence, vanilla essence. This is the compound that you may need to remember. OH, OCH3, and CHO. Okay. Tetra-substituted, you have to remember the word picric acid, 2,4,6-trinitrophenol, and trinitrotoluene. These two tetra-substituted you need to remember. Fused ring systems, naphthalene, anthracene, phenanthrene. Biphenyl is not a fused ring. And then pyrene. Okay. Now you start solving these questions. Come on, solve. Yes, if there are two possible base names, then prefer the one which has the preferred functional group, if there is a possibility. Okay, you will solve, then you will realize what I am saying. Solve and raise your hand for doubts, or give me a thumbs up to move ahead. Yes, Shrey, please speak.
I don't understand the second one.
You don't understand the second one. Let me. This one, bromine wala?
Yes.
See, all are prefix, na, Shrey? No one is having that special name like toluene, like anisole. Even if it was chlorine alone, it was chlorobenzene. Bromine alone was bromobenzene. Nitro alone was nitrobenzene. Nothing special is in there.
Okay. So we're
Then
just
we are
going by
having
local.
simple set rule. Yeah.
Okay. Thank you.
Are you guys able to do, or any problem you are doing or not? Show me some sign that you're doing, or else I'll move. Okay. Okay. Shrey showed thumbs up. Okay. Thank you, Shreya. All of you, when completed, then let me know. I'll move to next page. Thank you, Shiva. So it's time to move, I assume. Okay, do this. C11 number. I hope you accept what I have given the name. Right? Order was सबसे पहले secondary suffix, then the primary suffix, and once more important functional group is there, then whatever the other functional group will be given just as important as any other alkyl substance, nothing more.
Ma'am, I have a doubt, ma'am.
Yes, Sanjay, speak.
Ma'am, in the N1 bromopropyl and N1 chloropropyl, shouldn't we be using one dash and one double dash here? If in case we are having multiple substituents in that.
There in 15 number you are saying?
Yes, ma'am, 15, ma'am.
No, I don't think so. We need that because one bromopropyl, if they were on the same propyl, hypothetically that what it could have misinterpreted as, then it would have named one bromo, comma, hyphen one chloropropyl in the same bracket. If they are
Okay, so as you are putting enclosing it within brackets, such kind of numbering is not necessary.
not necessary here.
Okay, ma'am.
So now there is bicyclo, but it is not in JE syllabus. So I don't think we should do it. Right, and Spyro, which are again not in JE syllabus. So by that logic, that whatever not in JE syllabus, we are not doing. And so here we close nomenclature. That completes our IUPAC nomenclature. Kindly unmute yourself and let me know you want to go for GOC or isomerism. There are two choices. Either ways, it is same for me.
Ma'am, go for isomerism.
Okay, I have got one vote for isomerism. What about others? Either you write in chat or you tell. I have got one vote from Satvik. Go for isomerism.
Isomerism.
Okay, isomerism, 3 votes. One is a total, I think, class. They also showed for isomerism. Okay, no one else. I got 3 votes for isomerism. Shiva also, Shreya also. Okay, fine. And I think entire one class also said. So let us start then with isomerism. Fine. Okay, so let me start isomerism. So what exactly isomerism? I think initial part you all know that the word is mainly derived from so many languages. It is not a word from a single language we can attribute to. It is a word which is having its roots somewhere in German, Swedish, and all ultimately go back to finally Greek. Isos means equal and meros means part. So definition is molecules having same molecular formula but different structures, 2D or 3D, are called isomers of each other, right? And the possibility of existence of isomers is referred as phenomena called isomerism. Now, isomerism we will study in these type of bifurcations, these type of branches, like structural isomerism, which is also known as constitutional isomerism, stereoisomerism, which is referred as spatial isomerism. Okay, structural 5 types: functional, chain, position, meta, tato; stereo, conformational or rotational, that is the name of same type of isomerism. And then comes the configurational, which has GI and OI. GI bole to geometrical isomerism, OI is optical isomerism. Now let us start with functional isomerism. When we talk of functional isomerism, then it is such pair of molecules which have same molecular formula but different functional groups in them. Now we are not worried about what will be the count of members in parent chain, what will be the location of substrate, everything changing well and good, but if the functional group is changed, then you will just take answer as a functional isomerism, right? So but different functional groups in them are called functional isomers. How to identify? Always, this is the step for all identification of isomerism. Give IUPAC name to the 2 compounds given in a question. Compare the names and see what is the difference which is coming in that particular 2 compound IUPAC names. Difference if is related to, say, functional group, whether the functional group of a prefix or a suffix. Satvik, Satvik, take care, beta. What was that? Huh? So compare names and see the difference in functional group, whether it is a prefix or a suffix, whether the functional group difference is in the prefix terms or suffix. It is called functional isomerism. Now, there are enormous examples for functional isomerism, but cycloalkane and alkenes are also referred as ring chain isomerism, and certainly they are part of functional isomerism. Okay, main heading is functional. Like this is alkane and this is alkene, in and an. Okay, so the ring chain, when one of the isomer is a cycle, other is an open chain, they are also example of functional isomerism. So diene and alkyne we can have, aldehyde and ketones, they are functional isomers, alcohol ethers, unsaturated alcohols, aldehydes, ketones, epoxy, these are all functional isomers of each other. Okay, phenols and alcohols. See, the OH is directly connected to aromatic phenol, but OH is connected to sp3 carbon of the molecule, then it is alcohol. So they are functional isomers. Different degrees of amines are functional isomers. Esters and carboxylic acid functional. Okay, hydroxycarbonyls and carboxylic acid and ester, this combination is functional. Amides and aminocarbonyls are functional isomers, and so on. And nitro, iso, nitro, cyano, iso, cyano, and so on. Coming to chain isomerism, if the two molecules have same molecular formula and same functional group also, then but different root word for either the parent chain or the side chain. Okay, if the two molecules have same molecular formula and functional group but different root word for either the parent chain or the side chain. For example, here N-butane and 2-methylpropane, the difference of root word is in the parent chain. Okay, parent chain. Now here in example number 3, see ethyl pentane and dimethylpentane. This time the root parent chain is pentane in both, but the substrate split from ethyl to dimethyl. So then also it is a chain isomerism. Is that clear? Okay. Ethyl benzene, dimethyl benzene. These are chain. Identify pair of chains. So for that, you have to give IUPAC to all. And then you have to compare whether there is change in functional group or not, or is there any split of carbon. Then you can say yes, they are chain isomers or not. Okay. But every time, like in case number 3, I will not name them as chain isomers because one is al, one is on. I mean, one is aldehyde, other is ketone. So they will immediately be kept in a set of functional isomers. No need to be bothered about their chain isomerism. Is that clear? How to assign chain isomerism? For chain isomerism, it is compulsory to have same functional group. Coming to third type, which is positional isomerism, when functional group is same, okay, chains of both parent and substrate should be identical. These two conditions are set, and the only difference is in the position of functional group or the substrate. Now see, this is ketone, so 2 ketone to 3 ketone. Position is changed, na? 2 pentanone, 3 pentanone. Then it is position. Substrate is changed. Position of substrate is changed from 3-methyl pentanone, pentanone to 4-methyl pentanone. So it is positional. And you can check all of these. These are all set of positional isomers. 1-methoxypropane, 2-methoxypropane is positional isomerism. Is that absolutely clear? Right? 1,2-dimethyl. Yeah.
Yes, ma'am.
Okay. So 1,2-dimethyl propane. Okay. And similarly, I can have different positions named. Right? 1, 2, 1, 3, 1, 4. So these are all position. But when I have ethyl benzene, then it becomes chain. Okay. Coming to metamerism. Now, metamerism has a very basic first condition that it is present only in those functional groups which are either divalent or more. They can be trivalent possibility, but minimum divalent. That is the functional group like oxygen. It will have two sides na, in ether, two alkyl groups will be present. Esters, divalent. Here one group will be present, here other. 2-degree amines. As I said, trivalent or more is possible. 3-degree amine. Sulfonic acid esters. So like these, such functional group which will have alkyl on minimum 2 sites or more, then there will be a possibility of metamerism. When there is change in carbon chain on both, either on both or either side of divalent, then it is called metamerism. Like in ethers, okay, like this. 1 and 2 are called position as well as metamers. This was given in exemplar old edition. 1 ethoxypropane and 2 ethoxypropane, they took it as position as well as metamer. Okay, whereas you can see if that divalent functional group, one side 1 carbon, one side 3 carbon, and 2 carbon sets. So there is a change of carbons, metamerism. Whereas this, again, as per that exemplar, is again an example of chain as well as metamerism. Any change on one side of alkyl group also generates metamerism. Okay. See esters. Now, in ether, both sides were same, na? Oxygen, both sides were identical. Whereas in ethers, the bivalent functional group, but the 2 sides of that bivalent functional group are not identical. Right? One is attachment of oxygen, one is attachment of carbonyl. So here, that change is even if I simply exchange the alkyl group on the 2 sides of that bivalent functional group, then esters generate metamerism. For example, here where I am using my cursor, cyclohexyl benzene carboxylate and phenyl cyclohexane carboxylate, I have just exchanged the alkyls, then also it is metamers. Okay. Otherwise, you can just keep on increasing, decreasing the carbon side, one side, other side type. Right? 2, 1, 1, 2, 0, 3, like that. So I'm just varying the carbon count here and there. Then also it was metamerism. In ketones are special case of metamerism in which 2 pentanone and 3 pentanone are considered by their common names as methyl propyl ketone and diethyl ketone, and then they were said that okay, bivalent ketone functional group has different alkyls on the 2 sides, so it is a metamerism. Okay. Okay. How many isomers are there for? Now the type of questions which will appear, if they are simply referring to how many isomers are there for so and nothing, then as a rule you always consider structural plus stereo. Okay, whenever we are asked how many isomers and no specification, then we have to include stereo. Yes, if they want to write only structural, they will write how many structural isomers for, or how many only structural isomers for, like that language if there. Then you consider only structural isomers. Okay, find total structural isomers for. Please, without checking the solutions, attempt the questions because number of isomer questions are very important, and as many you do are always less. Right? More and more is better in terms of those. So please attempt without looking the answers. So that brings us closure of first lecture of isomerism, that was structural isomerism. Second is stereoisomerism. We'll just stop after 2 minutes, don't worry. But thoda sa karne ka. So stereoisomerism, molecules having identical molecular formula, similar bonds and sequence of atoms attached, but differ from each other only with respect to their spatial arrangement of atoms are called stereoisomers of each other. The possibility of existence of stereoisomers is known as stereoisomerism. So now the only thing is, always remember in stereoisomerism, position of the groups attached will remain same, position of bonds remain same, position of substance same, functional group same, everything should be identical in terms of who is bonded to who and is bonded at which site. That remains same. Only change has to be something with related to their three-dimensional visualization. On paper, you might not find any change. Okay, so that is why, as with respect to space, so it is also known as spatial uh, isomerism. The possibility of existence of stereoisomers is known as stereoisomerism. It is of two types: configurational. Configurational, they cannot be interconverted by rotation of bond at normal temperature and pressure. Conformational, they can be interconverted by rotation of bond. So those which are interconvertible are called conformational or rotational isomers. Those which cannot be are called configurational isomers. Okay. And how to represent these configurational or these arrangement conformational on paper, we'll be using two things. One is the Newman, other is the sawhorse. I hope you are already aware of what is Newman and sawhorse is. Newman, you visualize such that the front atom uh, covers the back atom. No need to visualize the bond between them, no need to write that bond. And then at the three corners of the equilateral triangle, you will direct the three bonds. While drawing Newman, the common mistake that people do is that they draw backside bonds also from the front center. This is absolutely wrong. Central carbon cannot have 6 bonds. So front bond from the center, back bond from the circumference of the back atom. Like that. You cannot put from the center only. Right? That is a precaution that you need to take. Sawhorse, just that bond which we were hiding is appearing, then it is called sawhorse formula or sawhorse representation. Okay, I'll be using a word dihedral angle. Okay, let me check, you have a following class. Okay, from dihedral angle, I will continue tomorrow. Now, first, those who have any doubt, please unmute yourself and ask. Others can start leaving and prepare for your physical class, physical chemistry class. Yeah. Those who have doubts, please unmute yourself and ask. Yesterday, Shiva, you were asking some question from Katna.
Yes, ma'am.
So now we can do. I have the soft copy. You were asking the first question.
Yes, ma'am. Cat first question, 37th question.
Yes. So here is the question. Let's put it on some empty page. Yeah. So tell. What was the problem, Shiva?
Ma'am, the first reaction, ma'am, the major product P.
It's a pinnacle-pinnacolone reaction, Shiva.
Okay, ma'am.
What they are doing is, see, you have to use this cyclohexane conformation. So position 1, 2, and this third butyl anyhow has to be on equatorial, that is fixed. Okay. Now if the third butyl is fixed, position 1, 3, 1, 2, or 1, 2, 3 here I will place cis. So NH2 is axial and OH is equatorial. So when NO plus HNO2 attacks and this form a diazonium and leaves, then when it leaves, this is at equatorial and this should also be at equatorial. Let me correct. 1, 3 to diaxial, diequatorial, na? So NH2 is coming here and then this is at this. So when this leaves, what happens that whatever is attacking from exactly backside direction will attack. So this oxygen cannot attack. This ring will undergo contraction. Okay, so from here, this carbon this carbon is taking an attack. And this is becoming CHO. Like this. So 1, 2, 3, 4, 5. Cyclopentane carbaldehyde will be formed.
Thank you, ma'am.
Okay, Shiva. Anything else from this paper? Nothing, just this much?
Yes, ma'am.
Okay. Anyone else? Nothing? Okay. So we'll continue our work again tomorrow.